Chi-square test is also called as a non-parametric test. So far, we discussed about the parametric test. One sample Z test, one sample T test, two independent sample T test, matched pair T test. In all the, even ANOVA, we discussed about, we compared the mean with the population mean. Mean is parameter, right? The population mean is parameter. Hence, it was called as a parametric test. For example, I have two factors. The two factors are numerical values. Sorry, the categorical variable. Okay, so that is called, in that kind of situation, we use chi-square test. In the previous case, we are using the numeric value. The mean is a numeric value, right? Average of something is average mileage, right? Mileage is a numeric value. You want to compare the numeric value with population mean average, right? It's a numeric value what you are comparing. So that is why it's called a parametric, whereas it's a non-parametric. There are cases you want to compare one categorical value with another categorical variable. So it is a strategy to assess the goodness of fit between a set of observed values and those expected. This is the formula that we use it. This is actually, it's not x squared, it's a chi squared, okay, is equal to sigma of observed value minus expected value whole square divided by expected. Very simple one. Observed minus expected whole square divided by expected. So what are the properties? It is based on frequency, not the parameters like mean and standard deviation. Hence, it is called non-parametric test. So what kind of scenarios can I use chi-square test? Association. We want to find out, are there any association exists between the two categorical variables? In that kind of situation, we can use chi-square test. Apart from this, you can conduct the chi-square test to find out the goodness of fit of distributions, and then to test a homogeneity also you can use it. But in the association analysis, the one widely used, this is what your, this is how it looks like, your chi-square distribution, okay? It is pronounced as chi-square, chi-square. It is written as something like this. In this case, the T, where the determining parameter of chi-square is the degrees of freedom, okay? Degrees of freedom equal to 7 and degrees of freedom. So it's kind of, the right distribution, okay? The chi-square test also. Distribution, okay? And okay, now get to the core of chi-square test for association. This is a null hypothesis alternative. In this case, we are going to make an assumption there are no association exists between two categorical values or variables. Alternative is the opposite. Yes, there exists a association between the two variables. Okay, and for let's take this case study. It's a very interesting one. Let's say you have two categorical variable. One is outcome. What happened? This one is not working. Yeah, you have two categorical variable. So one is outcomes, the other one is hospital. Within the hospital, you have different categories. The Triple M Hospital, My Heart Hospital, Apollo Hospital, SRM Hospital. But in the outcomes, but all these things falls under hospital. This is one factor. The other factor is the outcomes. But in this case, both of them are categorical value. Here we are not going to use mean and all. Okay. But the outcomes, for example, a patient got admitted for the kidney surgery, kidney replacement. Here we are going to, we have sampled the data, and then under these three categories, a complete recovery. Sorry, in this case, yeah, three category, right? So the outcomes could be complete. That means, the patient, the surgery was successful. And then what about the other one? The partial recovery. The surgery was okay, over, but still is not recovered completely. He needs some more treatment. Okay. There are cases death, right? So we tried our level best, is suddenly his heart rate went down. Nothing could be done. Okay, death. So these are the three chances. These are the three outcomes when a person undergo for a kidney replacement. We just think that way, okay? The Triple M Hospital, what is the success rate? So 18 patients, surgery was done successfully, and likewise, we noted down here. By looking at this itself, we can make out in Apollo Hospital, the complete is very high, right? The success rate is very high. partial recovery is less compared to other hospitals, and the death is less. But still, we need to conduct the test and then we need to decide it. So what is the formula for conducting the test? So in the Excel, it's very simple one, chi-test. Okay, what I will do is I'll just show you here. In Excel, I'll just simply plug in the values. Chi-square test. Look here. In this case, I just say I'm going to use these two tables. We need to find out the observed versus the expected values through the test. Okay. Okay, I just copied here. In this case, what are the outcomes here? The outcomes are complete recovery and a partial recovery. Partial recovery. And in this case, the death. You're just plugging the value 18 and then 50 and then the Apollo. See here, we are not taking the mean. We are just taking the count, right? Number of occurrences. How many number of patients survived or how many? What is the success rate? Partial recovery is 9, 28, and then here the 15 and 12. And here the death is 11, 12, and 5 and 10. In this case, you need to find out the column level total. And then row level total you need to find out. Okay. And here the row level total equal to sum of all these values. See, next class onwards, please enable the video, okay? Because it will make the session more productive. Without fail, enable the video, okay? And this is your total. This is your row total, 144, right? 5200 row total. This is your grand total. And this is your column total. Each column, what is the total, right? If you add all the values, you will get something. If you add all the values, you need to get this value, okay? Fine. And the next one is, this is your actual value, given data. And you need to derive something like expected values. How do I find out the expected values for the same thing? I just copy these things. I just put it here. And then in this case, we need to find out. So this is the formula that you need to use it. Column total into row total divided by grand total. For example, in this case, what is the column total here? 38. 1 second, I'll use the parenthesis. The column total into the row total divided by the grand total. Press enter. That's it. Same way, you need to do it for other columns. So in this case, obviously, what the column total will vary, right? And this one, sorry, and this one into column total into row total. Yeah, so for this one, you need to take this one divided by the grand total. Okay, likewise, you need to find out. Once you find out, we have something called the chi-square test. In Excel, we have something called equal sign chi-test. Yeah, chi-square, chi-square, chi-test. But here, yeah, in the latest version, you have chi-square test. In this case, you need to select all these. These are called your observed values. Sorry, these are called your observed values, which means the given values, actual values. These are called your, listen, these are called your observed values, comma, the expected values. So these are called your expected values. See, expected values, how did we arrive at? I just click on it here. Row total, column total into row total divided by grand total, right? That is what we did. And then when it comes to this one, it is related to MyArt, right? It is, so in this case, the row, this one, this column total into row total divided by, one second, sorry, here, let me just check. Grand total, degrees of freedom, column minus one, row. Okay, here the p value is okay. Grand total, column total, row total. Yeah. So this is what your row total and column total, right? Yeah. So for this one, yeah, sorry. So 38 into the row total is 144 divided by grand. Yeah, here I made a mistake. Here also the same thing. Okay, 144. Here, what is the row? M4, right? Here M4. M4, J7 90 into row total divided by grand total. Okay, and then here the same. Here what we need to do is we need to put this one. In this case, okay, better we will type it here. Okay, I just use this column total into the row total divided by the grand total. You need to use the parenthesis. Okay, once you start with using the parenthesis, you need to make sure that you end with that one. So, and the last one is this one, 32 into the row total divided by your grand total. Okay. We got. Similarly, you need to find. So in this case, when it come to this one, and here we need to take this one because we are in the second row. Okay, and sorry, this one I7. Sorry, here you need to select this total into the second row. You need to select it divided by the grand total. Okay, that's all, guys. Similarly, you need to compute for the all. Here we have 4 columns, right? We have 4 columns, and the same thing. These are your observed values. Okay, you can, if you want, you can use the total here also. Okay, and these are the things not required. I'm going to say something like no border. Okay, fine, you're done. Okay, the same way. So I'm going to remove this one. Okay, you need to find out the same. When it comes to the third row, you need to take the third, this column total is same, but the row total will vary because for third row, you need to take the third row total. So column total into row total divided by this one. Okay. And that's how you need to compare. Whatever the value that you get it here, that is called your expected values. Expected values. So column total into row total with grand total. That is the one will give you the expected values. Okay, for the first row, Obviously, for all the rows, we need to take the column total. But when it comes to the row total, you need to pick up the corresponding row. Well, right? For this, you need to come. For this one, you need to come here. Okay. That's how. For in the case of death, how will you find out? I'll just put this one, so that you can make sure that you are not making any mistake. Okay, 38 into the row total is 28 divided by this value. The same way, I want you all to do the rest of the text and then find out the total. That's all. And then use the chi-square test. Okay, the chi-square test and select the, these are observed values, comma, the expected values. That's all, guys. Look here, I put the formula also. If you click on it here, everything is ready. Okay, only thing is you need to fill these values by following the same formula. Okay, that's all. With this, you will get the p-value. Since the p-value is nothing but, the p-value, right? This is the p-value. The p-value is less than alpha. Obviously, this is less than alpha. Alpha is 0.05. P-value is very, very less. Hence, we are going to reject the null hypothesis and we are going to conclude that the outcome does, the hospitals have an association with outcome, or the outcome is depending on the hospital, right? If you see Apollo, the outcome is really good. Obviously, they charge more, but the outcome is really good. To my, that is the reality. Okay, in my